Okay, here we're going to look at functions where you have x both in the base and in the exponent. This is another place where logarithmic differentiation is useful. In fact, the previous stuff we did, those were problems that we could have done without logarithmic differentiation, but logarithmic differentiation made those easier. This, though, where you've got x in the base and exponent, we can't do these without logarithmic differentiation. So let's look at this. The classic example, or the simplest example, is y equals x to the x. This is a function that grows crazy fast. But let's take its derivative. If we take the natural log of both sides, first thing we're going to do here is bring this down front using the power rule. Now keep in mind, that looks an awful lot like taking the derivative, but it's not, because it's just using the logarithm rule. So we get this, and now we can take the derivative of both sides. Over here, we're going to have to use the product rule. So derivative of natural log of y, remember the thing goes on bottom, its derivative goes on top. And over here, we'll do the first times the derivative of the second, plus the second times the derivative of the first, and derivative of x is just 1. So I've got y prime over y is equal to 1 plus ln x. So 1 plus ln x there. Now we've got to multiply both sides by y. And so that gives me y prime equals 1 plus ln x times x to the x. And that's my answer. We could graph this on Desmos and verify that this is what it gives us for the derivative, but let's don't do that. Let's go ahead and look at a couple more examples. All the examples that we're going to see for this are going to look similar. The ones in the homework are very similar to this, where you have a trig function raised to the x, or maybe you've got it raised to the natural log or something like that. But let's do this. Differentiate y equals tan x to the x. All right, y equals, or ln y equals ln of tan x to the x. So ln y is equal to x ln tan x. So you get y prime over y. First times derivative of the second. Derivative of natural log of tan. Tan goes on the bottom, and the derivative of tan goes on top. Derivative of tan is secant squared. Plus the second times the derivative of the first. Maybe it's worth coming over here and writing this. This is the first, and this is the second. Don't mistake this for multiplication or anything. This is multiplication, but natural log of tan is just, nested function. So let's see, this is y prime over y. There's not really much we can do here. We might be able to rewrite this in terms of sines and cosines and maybe cancel something, but let's don't worry with that. Let's just rewrite this as x secant squared x over tan x plus natural log of tan x. And then we've got to multiply both sides by y. So over here, I'm just going to multiply this by tan x to the x. And that is our answer. Now, that's kind of a nasty function to start out with, and the derivative is pretty nasty too. But anyway, that's it. All right, let's do this last example. We've find the derivative of this. So we take ln of y equals ln of ln x raised to the sine x. All right, so you get ln y is sine x times ln of ln x. All right, so we've got to use the product rule again. We've got our first and our second. So derivative of natural log of y goes on bottom, y prime on top. And now we got to do the product rule. First times the derivative of the second. Okay, this one is, we've got natural log of natural log. So when I take the derivative of the second thing here, we work our way from the outside in. So derivative of natural log here, we move this natural log to the bottom. And then we take the derivative of natural log and put it on top. So we get 1 over x over ln x. So that's first times derivative of the second. Maybe that's worth labeling. So f s prime plus the second function times derivative of the first. Okay, finally something easy. Derivative of sine is just cosine. So let's label that. All right, so we get y prime over y is, I'm going to combine all this into a single fraction for this part here. Notice this piece right here, this can be rewritten as 1 over x ln x. So I can rewrite that, I can rewrite this whole term here as 1, as sine x over x ln x, then plus ln of ln x cosine x. Then let's multiply both sides of this by y. My original y was ln x raised to the sine x. And that's my answer. All right, that's it for this section.